Hello there. So we are going to continue on with our kinematics in 1D. This is the last video for this unit. It's all about acceleration due to gravity. It's continuation from last class, so hopefully last class made sense, and this one will too. It's just one slight change. Our purpose is we want to know what is acceleration due to gravity, and we're going to solve some problems involving acceleration due to gravity. You might have heard this term before. Any object that falls, it's going to fall at the same rate if you don't have friction. So you might have seen a video of astronauts on the moon. They have a feather, they have a hammer. They drop the two of these at the same time and they hit the ground at the same time. If you don't have friction, like air friction, air resistance, things fall at the same rate. On the surface of the Earth, it's 9.8. Now, technically, it's not exactly 9.8. It depends on where you are on the Earth, but this is the average acceleration on Earth. So really how we solve these equations is exactly the same as last class. The only thing that's different now is if something is falling or it's moving through the air, your acceleration is going to be negative 9.8, negative because it's going down. So for example, in this one, we've got a student dropping a toothbrush off a building. After 3.3 seconds, the toothbrush hits the ground. We want to know how tall is the building. So in this question, we're told that the student drops it. So the initial velocity is 0. You're given time, 3.3 seconds, and it asks how tall is the building. So what's the distance? Now this looks like we don't have enough information. We've only got 3 out of the 5. But like I told you, if something is dropped or it's falling, your acceleration is going to be negative 9.8. Again, negative because it's going down. Don't forget the negative. This gives us our fourth bit of information. So read the question carefully to figure out if something's dropped or flying through the air, you're going to have that acceleration. So we take the equation that does not involve the final velocity. Notice here, because my initial velocity is 0, 0 times t is just going to go to 0. Let's plug in some other numbers, and then from here you just plug that in the calculator. Notice here I've got a negative displacement. Again, negative means it went down. It's not asking for what's the toothbrush's displacement. It's asking how tall is the building. So it's asking for a distance. We want to include the 53.36 without the negative. We just want how high. We don't need a displacement. So this is why you need to know what's the difference between a scalar and a vector to know how to write your final answer. This is the confusing bit. Next question, we've got an expensive laptop that's thrown straight up in the air, and we want to know a couple of things. First, we want to know how high does it go. And we are told that the initial velocity is 8.4. It's thrown up, so it's positive. We want to know its displacement. That's all that's given in the question. So we need to think, what other information do we know? First of all, just like last question, acceleration is negative 9.8. The other thing that is important to note is when an object is thrown up, at the very highest point, so if an object flies up, at the very highest point, your velocity is going to be 0. So with these 4 variables, and knowing that we don't need time, let's use the equation that does not involve time. We'll plug in the numbers here, do a little bit of algebra, move the 8.4 squared to the other side. I times the 2 times the negative 9.8, divide by negative 19.6, and we get a distance or displacement of 3.6 meters. That is how high this object is going. Again, note with this, the velocity at the maximum height is always going to be 0. So at max height, you're going to have 0 velocity. Part B of this question, we want to know what's the total hang time. Hang time is just how long is this object in the air. So we have some similar information from last time. We know the initial velocity, we're looking for time, we know the acceleration, and what we're going to do is we're going to calculate the amount of time it takes to go to the maximum point. So we're going to assume that the final velocity is 0 again. And we got the displacement from last time. So technically we know all the variables except for time. So it doesn't matter which equation you use. I'm going to pick this one. It's the easiest one. Plug in some numbers, do a little bit of algebra, we solve for time. Okay, so now that we have the time, this is the time it takes from go to the lowest point up to the top. But it doesn't ask the hang time to get to the top, it wants the total. So we go from the bottom to the top, back to the bottom. The time it takes to go to the top or the peak is the exact same time it takes to go back down. So we're going to double this time, and this is going to be the total hang time. So note with this, the time it takes for an object to rise is the same it takes to fall to the same displacement or distance. So from bottom to top is the same time to go from top to bottom. So that's one little trick you need to know with these types of questions. Another example here, we've got a squirrel standing on the top of an acorn tree. They throw the acorn straight up. we want to know a couple things. First of all, we want to know how long does it take to come back down to the same height. So if here's the tree, the squirrel standing at the top of the tree, there's the acorn up. We want to know how long until it reaches that same point. So not to the ground, to the same point. So some information that we know with this are initial velocity, we're told that. We're looking for time, acceleration, always the same, something's in the air. Another trick you need to know with these types of questions, if an object is thrown up with some speed, once it reaches that same distance, you're going to have the same velocity but in the opposite direction. So if the squirrel's at the top of the tree, if it throws it up at 5.2, when it comes back down at that same point, it's negative 5.2. So let's solve this with the equation that doesn't involve d. Plug in the numbers, so we're going to minus the 5.2 onto the other side, divide by negative 9.8, and this is the time it takes to go from the top of the tree up and back to the top of the tree. So again, just a note, you can write this down in your notes there just to keep track of this. Speed going up is the same as the speed going down when you're at the exact same height. Again, this is with projectiles if you throw something up. All right, under part B, so if this acorn goes up and then it falls all the way down to the ground, we want to know what's the impact velocity. Impact velocity just means what is the velocity as it hits the ground, not after it hits the ground, as it hits the ground. So we have some information that's already given. We know the initial velocity, we know the acceleration. We want to know what's the final velocity. And our displacement in this case is negative 15. So again, from where we start to finish. So the acorn's at the top of the tree, it goes up, and then it falls to the ground. So the difference between where it started and where it finishes is negative 15. It went down. We don't care about this up and down bit, just from where it started to where it finished. Take the equation that doesn't involve time, plug in our numbers. On the right side, we just plug all that in the calculator. We get this. Now we take the square root. So when you take the square root, it must be plus or minus. This is why I warned you last unit with algebra. If you square root something, you need a plus or minus. Based on the situation, it makes sense that my final velocity is negative because it's going down. So I must include that as negative. But again, negative could mean west, it could mean south, it could mean down, it could mean left. So I want to be as precise in my answer as possible. So my final velocity is 17.9 meters per second downwards. We know it's going down into the ground. So again, reminder, be as precise in your answer as possible. Leave the negative if there's no directions. But if there's a direction, make sure to be as precise as possible. Put downwards, put west, put south. Make sure you put those in the answer. So I know that you know what that means. There you go, that's the finish of kinematics in 1D. So that is everything. Make sure you remember big three equations for accelerations. If there's no acceleration, v equals d over t. And next unit, add a second dimension. So instead of something going up and down, now the acorn's gonna get thrown sideways. But we'll get to that next unit. So this next clip is from Iron Man 2, I believe. I believe it's from the second one. So this one, take a look. There's no special introduction for this. It's going to be a short clip. Take a look and see if you think there's something wrong. All right, very, very short, like I said. Okay, so yeah, there's definitely something wrong with this. If you have seen the movie, maybe you didn't see the inside of the Iron Man suit, but he's got essentially very little padding on the inside. So as he's falling down and he goes into his superhero landing, he is basically going to be squished inside of his suit and turned to jelly because he just decelerates way too fast. Way more fast than what a human body is capable of. So if I show you this again, take another look, his innards are going to be mush. So already he's accelerating downwards, his jets are firing him down, and that at that rate, that is going to kill anybody. Even if you're inside of an Iron Man suit, there is no cushioning that he has. That's not going to feel good.